Okay, so back from break, we were just discussing what we should implement next. We've got something that authenticates against a plain PHP array in memory. So the test looks like this. We create a user's array, we give it to this implementation, we run the authenticate method, and it tells us whether this authenticates true or this authenticates false. We're also validating that for this implementation, all the objects provided are arrays, not objects. All the variables provided are arrays, not objects. That was very confusing. And so we're going to carry on with this. GamerCoder suggested that we do that we make a part of this library that we can use as a JSON server. So we can create a new instance of this class, we can feed it some data, and it will create, yes, yes, changing scene. I figured that out too late. Shall I summarize again? We have this class, we make an array of users, and we give it to an instance of this. We have an authenticate method, this will return true, and this will return false. And we're also validating that everything we give it is an array. Okay, please excuse the noob streamer. So, GamerCoder was suggesting that we have a way to host a JSON API to be able to do this stuff kind of easily, that we can use this in any other website that may not necessarily have the infrastructure to doing a JSON API, but just something easy to use, right? So that sounds like a really good idea to me. I was thinking a little bit about this, and I thought it might be cool to reuse this authenticator interface that we have here, make the class that serves a JSON API, but accepts an array authenticator or an authenticator interface implementation, so that the authentication is done over get parameters or post parameters or whatever, but that it goes through an underlying authenticator library, just so that we can reuse code a bit here. Okay, so what would we call this kind of thing? Authenticator, maybe we would call this endpoint. Maybe let's call this endpoint. That kind of makes sense, right? It'll be a JSON endpoint. It'll use an authenticator. So if we go here, we'll just call this endpoint. And what do we want to do here? Well, let's not think about this in terms of the asynchronous stuff we've been doing recently. Let's think about it in terms of a traditional framework-based web application. How do we want this to work? Traditionally, web applications boot for a single request, the whole framework boots, and then a router boots, and depending on the address given to the application, it will route to a specific endpoint. So let's imagine that we have somewhere in our application, in our MVC application, because of course it's all MVC these days, that we have a controller action, and in this controller action, we want to create a new instance of this JSON endpoint class, and then we want to say, okay, here is how I authenticate. This is a back-end authenticator, and it connects to a database and it gets users from that. I will give you some data. I will give you some credential data, or like an array of post data or something. No, forget about that. I'll give you some credential data. I want you to serve me a JSON endpoint or an XML endpoint to say whether this authenticated or not. We can do that. That sounds easy enough. Maybe we'll use exactly the same signature here. Maybe that's what we'll do. In fact, maybe we don't even need to call this a separate thing. Maybe we can just decorate this. Maybe we can just have a folder of decorators around an authenticator. And what they return isn't necessarily the Boolean value, although the interface says Boolean, right? The interface does say Boolean. So maybe that's not what we want to do. Maybe this authenticate method, exactly the same signature works, but instead of returning a Boolean, which our tests specify, our dot blocks actually don't specify this, maybe what the endpoints return is a string. Yes, a string. String seems logical. Okay, so we still call authenticate with an array of credentials. In our controller action, remember, we will have access to the request that was made. So we can get the post variables from that request, or the get variables, session variables, whatever, and we can provide those to this authenticate method. Now this will wrap around an authenticator, which means the credentials are going straight to that authenticator, and this endpoint is only interested in the Boolean value of that. But then what this endpoint gives out for an authenticate request is a string of XML, a string of JSON, a string of whatever. I think those two are significant examples. Return sting, yeah, yeah, return sting, of course. Okay, so we have an interface here. Let's just make one implementation of this for now. So JSON endpoint. Oh. Let's try this. Make new file. Endpoint JSON endpoint. Will that work? Yes, it does. I should totally use that dialog more than the make folder thing. Okay. I'll take. Well, I'll just write this out. Okay, so the namespace is namespace sesame for Open Sesame. It's also in the endpoint directory. We have to use Sesame endpoint interface because that's in a different namespace. And the class is JSON endpoint implements endpoint. Okay. Now we have to have this method signature here again. Okay, what was this? Why did I delete this? That's pretty dumb. Okay, we have to have this method signature here again, so let's do that because we know we're going to need it, and we'll not implement anything yet. Okay, but let's make a test for it. Let's say endpoint folder, JSON endpoint, I have to correct that, JSON endpoint test.php, and let's copy this stuff out because it's quicker than it's going to be quicker than typing it all out again. So delete that and delete that and delete all that. JSON endpoint test. Okay, this is also in the endpoint folder, so we'll do that. Okay, what do we want to test here? Remember we discussed this is the same method signature, sort of, almost, as our authenticators, but instead of returning a Boolean, it returns a string, and that string is a representation of a response. So it's still going to be up to our controller action to set things like header and content length and that kind of stuff, but at least it will have an already formatted string that it just has to return to the browser. Does that make sense? How do we want to test that? Well, let's have a look what we're doing in Array Authenticator test. We're testing authenticate. That seems fine. Yeah, so we're testing authenticate and then we're testing some validation over here. Well, let's test for it like this. Let's say public function test. What are we testing? Test wow, I really spelled that wrong. Authenticate. We'll call this test authenticate again. Did we call it test authenticate or test authentication? Why didn't I just copy the method name? So much simpler. Okay, so what we'll do is we'll say new endpoint is wow new JSON endpoint, and this assert equals. In fact, we'll even alias expected here. Expected. We expect this to return to us a JSON encoded string. Do we want to format it like this? Do we really? Maybe I'll just make it a plain string. Okay, so it will return an object to us. That object will have status. Do we want to do status or do we want to do authenticated? Authenticated. I think that's better. And this should return true. In fact, we can test for two different things here. We can say something like, we expect authenticated true for a successful request, and we expect authenticated false for an unsuccessful request. We can even strip some white space here. In fact, let's make this quoting even simpler. I want these tests to be as readable as possible. Yeah. Correct the namespace. Ah. Wow, that was horrible. Okay, so for a successful authentication, we expect authenticated is true. For an unsuccessful one, we expect authenticated is false. Now, how do we get those? Well, we say endpoint authenticate, and we'll give some credentials here. So let's borrow the credentials that we have previously here. Users, I don't know if I'm going to keep this here for very long, but I'll say something like username and password. And remember, we'll copy those. In fact, we'll copy this whole thing here. We'll copy this whole thing here for the second authentication request, but we'll just change the name. So we know this won't match, right? Okay, that's how we expect the interface to work. I'll comment this out for now because I want to do something interesting with that. This is how we expect the interface to work. How do we get it to be like that? Run test. Okay, interface, Sesame, authenticator not found. That's interesting. Okay. Endpoint. Oh, what? Array authenticator, line 9. Wow, I just nuked the previous implementation of this. Hilarious. Okay, so these signatures are almost identical. It's just that the one is supposed to return sting and the other one is supposed to return bool. Sting not found. Okay, so the one returns string, the endpoint returns string, the authenticator returns bool. That's the difference between those two. Otherwise, they're exactly the same. Okay, let's run this again, get a different error. So JSON endpoint not found. Okay, so we're not aliasing this in our thing here, right? Let's do this. Use, it's in here, and the class is JSON endpoint. Okay, do we get a different error? Yes, we do. Okay, failed asserting null matches expected string. If we have a look at this, you see it's because we're not implementing anything yet. But this gives us an interesting thing to consider. Remember back to how I said we could implement this, that we could have the endpoint interface wrap around an authenticator interface so that we don't redo that authentication logic. We can use any kind of endpoint to wrap around any kind of authenticator, and it should just work all the time, right? So ideally what we want to do is we want to accept an authenticator as a constructor argument to an endpoint. But we don't really need to have that in the interface. It's not really important for the interface. Let's just say for now, public function construct, and this accepts an authenticator we can type in this, so it's even easier than having to do our authenticator stuff. But we need to use this, right? So Sesame authenticator, because we need to get that interface into this namespace. We also need to store this again, so I'm going to use a private again for this. And we can just say something like this. I'm going to delete that $. Is that? Okay. So we can't create an instance of this class, of this concretion, without giving it an authenticator. But once we have that, it's stored. Let me just make sure that all these spellings are the same. Yes. Okay, right. So what does this do to our tests now? Now we have a new kind of error. The constructor must implement the authenticator. And that makes sense because we've just coded that. But it gives us a different problem to worry about. Now we have the question of whether we make true unit tests or whether we make functional tests. And this is kind of a loaded question, right? Because I haven't explained the difference between the two. And if you're unfamiliar, unit testing is this process of trying to test as little individual units as possible. So we made an authenticate method, we tested that authenticate method. We made some logic to validate input, we made a test just to test that logic. And when you're unit testing, you want to have tests that test just the smallest amount of useful stuff possible. Now the problem comes in where we're actually testing JSON endpoint, right? The code here, it's meant to test JSON endpoint. But to make this, we need to create an instance of Array Authenticator. So now problems in Array Authenticator can roll on to problems in JSON endpoint. If we make a breaking change in Array Authenticator, our tests for JSON endpoint are going to fail, and that's not exactly what we want to do. That's the main difference between how I understand unit testing and functional testing to be. Unit testing goes out of its way to make sure that you're testing just one thing at a time, and functional testing says, well, I'm not really fussed. If I have a break in the authenticator that breaks the endpoint tests, that's fine. But you test still small sections, but you don't mind if you incur additional dependencies that you're not testing. How do we do functional testing here? Well, we can basically just copy what we've done with Authenticator here, right? We can basically copy and paste this stuff here. And then we give Authenticator as that argument. And then, well, we're giving... I need to have an alias here as well. I need to have an alias. I'll put it separate because I'm going to delete it right now. But we do that, and then the error becomes something else. It's no longer complaining in here because we don't have an authenticator. We've given that. So we can say something like return JSON encode. We can make this thing return the thing that we want. Authenticate. And this will be this authenticator authenticate. We can do that, right? This fulfills the contract. In fact, if we run the tests now, there's a subtle difference with them. It's that authenticated is what we're looking for. So if we run this again, okay, this passes both the successful test and the unsuccessful authentication test. But if we go back to our JSON endpoint test, now we're not just testing JSON endpoint, we're also testing Array Authenticator. And that's the difference between how I understand functional testing to be, which is this, and unit testing to be, which is what this is not, which is just testing JSON endpoint. How do we do that? It's a bit of a purist thing, right? Let's use a library, because I don't like there's this concept called mocking, and I don't like PHP Unit's default implementation of this, so I'll do something like composer, require, mockery, I think this is the namespace for this. Pretty sure it is. Let's just check this. If you're looking for PHP libraries and you're not sure what they're called or what their dependencies are, you can go to packages.org. And you can search for it here. So I'm going to search for mockery and we can see what this is called. Okay, so it is called mockery/mockery. This is a really useful site. It shows you what stable versions are available, what the requirements are, some stats on that stuff, maybe a description if that's in the README. That's pretty cool. Okay, but I guessed it right from the beginning. So compose require mockery. This is searching for and will install the latest stable version of mockery that is compatible with the other dependencies I have here, I think. I mean, it may not even check this stuff. But because I'm running this through PHP version 5, PHP-V, because I'm running it through PHP version 5, it will find a version that's compatible with version 5. Okay, so it's picked 094. Now remember what I was saying about semver? This code here says that Composer, every time I do a Composer update, it will install 0. Any minor and patch version. That's what this caret symbol means here. So until version 1, it'll install every minor and every patch version, which is pretty cool. I'm going to delete 0.4 because I don't really need to specify that. I don't really want to specify that. I just want to have a major and minor version as minimum. Okay, so it's installed this stuff. Now, we can use mockery in our tests. We can use them to simulate the presence of classes without actually having those classes there. And I'll show you how this looks. Remember I made a common test case class here, and all my tests extend this? Well, I'm going to do some shared functionality here. To use mockery, we construct these interesting kinds of objects. And before any tests are run, we need to just call a cleanup method to seal those objects so that they make sense to PHP units, so that they trick PHP units successfully. To do that, we need to use mockery. And then we need to have a special method in PHP unit called public function teardown. This is run after every single unit test is executed. We must remember to call the parent of this in case PHP unit needs to do anything special with this. And in here we'll say mockery close. In fact, I think it's like this actually. Close. Let's just run this and see that it doesn't give us any errors. Does it give us those errors? Class mockery not found. Interesting. Okay. GitHub mockery. I can't remember exactly what I'm doing wrong here. So I'll go and have a look. Where's the example for this? Docs mockery. Sure, I'll go elsewhere for the docs. Okay, simple example. Okay, it's just use mockery. It's not use mockery/mockery. My bad. Okay. Again, our tests are passing. Remember, because we're still doing functional tests. We're still creating an instance of a class we're not testing and using that as a dependency. Now, how do we start to use this? How do we start to use mockery to create these interesting objects I was talking about? Well, to begin with, we have to use the mockery class, just like we did in the base abstract class that we create all our tests to depend on, to extend. We do this, and then we say something like mockery, mock, and we tell it the name of the class we want to mock. So in this case, it's going to be this class here, the array authenticator class. And to be honest, it actually doesn't matter. It actually doesn't matter whether we use a concretion or an interface. In fact, it's probably better that we use an interface because that makes our tests very clear. What are we using as a dependency? Anything that implements this interface. That seems to make sense. So let's use this interface up here, just so that we can use a shorter form of it. And then we'll say, okay, I want to create an interesting mock object of this class, authenticator class. Now, there is a very broad terminology for things like mocks in testing, in the world of testing. It's even broader than the different kinds of tests. Like I spoke about unit tests and functional tests, and there are really lots of different names for different kinds of tests. When it comes to mocking, or the concepts similar to mocking, there are many different kinds of objects. And so I'm just going to use the word mock, the name mock, to refer to something that is a fake version of something real that you don't want to use. That's what I'm going to use to describe it. I may use it interchangeably with some of those other names, and if you know a lot about that, it's probably going to annoy you. I'm sorry about that. But if you're new to this, it can be very confusing. So what I'm doing is I'm using the word mock to refer to a thing that is a fake version of something real that you don't want to use. It's perfect for what we want because by default the mockery mocks create objects that implement these interfaces. So our constructor is still going to pass. So clam, charter, whatever, PHP. I'm programming PHP. I'm doing some test-driven development. Is that how you pronounce that? CLVM. I'm just going to say clam charter because that's what it looks like you're trying to say. Is that what it looks like you're trying to say? Okay. So we're making a fake object of anything that implements this interface. And the way that it's made is that it implements the interface so that our constructor validates correctly, right? But it doesn't actually have any methods according to this. However, it allows us to expect certain methods and to return certain responses so that our tests can be very predictable. We can say, for instance, that mockery should receive a call to the authenticate method. Okay, it should receive a call to the authenticate method. And when it does, it should return true. So let's comment this test out just for a second. And now we also need to create an instance of this. So now we've just created a mock object and we've said you, even though you have no functionality in you, you should receive a call to your authenticate method and you should return true. How does this work? Let's see if this works. No, it doesn't. Sesame authenticator. Authenticator class, Sesame authenticator. I'm doing something wrong here. Mockery mock authenticator class. What happens if I use a concretion of this instead of the interface? I just want to check something quickly. What if I use a concrete class? Mockery mock. Oh, I think I know what's going wrong. Okay, so the first thing has to be just mockery mock, and then we say that mock should receive. So then we start building what methods this thing should expect. We can actually just have some new lines here. Okay, so make a mock of this interface, and then this mock should receive a call to the authenticate method and return true. Streaming Raz, I lived in South Africa for many years, like 27 years, and I've recently moved to New Zealand. So I don't speak like a Kiwi, I speak like a Cape Townian, a South African. Okay, let's run this again. Now, remember we commented out this false test because we're not dealing with that mocked functionality yet, but we have 3 tests and 4 assertions. That's because our array authenticator tests in a different test case, they're being run and they're passing. But this mock is passing the first time it's run. It receives that call to authenticate because the JSON endpoint class still thinks this is a real authenticator and it returns true. What happens when we uncomment the second test? We have a failure because our mock is always going to return true. The second time we run this, we want it to return false. How do we get around this? Well, yes, I'm from the moon. That's an interesting observation. I am from South Africa, and there are many people who look like me there. So the first time, in fact, every time we call the authenticate method on this mock, we're going to get true. And there are ways around this. Probably the least confusing way around this is to just add a second should receive authenticate, and this time return false. So the first time this is called, it will return true. Every other time it will return false. Does this make this pass? No, it doesn't. Maybe we do it this way. Maybe we override it. It's been a while since I've used mockery. No, expected is false and it got true. Okay. So, interesting. Okay, let's move this credentials thing out. I've got to try and remember how this works. Okay, so authenticator should receive authenticate. I mean, the alternative is that we could... Do we want to do that? No, okay. So we create these credentials and then we say, okay, authenticator should receive a call to authenticate and it should return true. But it should return true when it gets called with good credentials. I'll just rename this over here. So the good credentials, then it should return true. I use material design theme for Atom. I think that's what it's called. Atom Material UI.